Hello, nice to see
Hi
you.
there. Hello there.
I'm really pleased to have Professor Suzy Moat with us. So I was trying to think of, what would be a great way of kind of rounding off this event about this idea of how do we accelerate research using really deep insights into the domain, but using new technology. And I thought, you know, this is really Suzy's work is really a quintessential example of exactly what we're trying to do, this kind of using these methods to really understand the patterns of behavior. And so Suzy's a professor of computational science and runs the data science lab at the business school at Warwick. I'm not going to say much more, and I'm going to turn it over to you. So thanks for coming virtually.
Thank you very much indeed for that very kind introduction and the invitation. Let me just share my screen. There we go. Excellent. All right, so thank you once again. It's an absolute delight to be here. So my name is Suzy Moat. I'm a Professor of Behavioural Science at Warwick Business School. And I'm also a Fellow at the Alan Turing Institute, the UK's National Institute for Data Science and AI. Now, my background is a mixture of computer science and psychology. And for many years, people would tell me that this was a really odd combination. But over the past few years, things have really changed. And as you'll all realize, so much of what we now do generates data. Now, at Warwick Business School, I have the huge honour of directing the data science lab with my colleague Tobias Preis. And in our data science lab, we're interested in data from the internet. So data on what people are searching for on Google, data on photos that people have posted to services like Instagram, or data that we can collect from games that people play online. Now, over the past few years, we've looked at whether we can use this data to predict human behaviour or to measure human behaviour that was previously just so expensive or so time-consuming to capture. But we've also looked at whether we could take data from the internet and a little bit of AI and use that to measure elements of the world that we live in that we simply couldn't measure before. And that's what I'm going to talk to you about today. Now, here in the UK, we're not known for having the world's most wonderful weather. That's a reputation I fear we deserve. But partially thanks to our very famous weather, we have some really beautiful locations too. So consider this picture. This is a picture of the Lake District up in the north of England. Now, I really love the Lake District. I grew up not too far from there. And when I was younger, I used to really enjoy spending time there because it's beautiful. And being in this beautiful environment would make me feel better. Now, up there in the top right-hand corner, that's Chanuki Sarasinya. So Chanuki recently completed her PhD in our lab. She's a very talented researcher. But before she started her PhD, she actually had a really interesting career doing some other things, including running her own design agency. So Chanuki really had a sense for how the way things look can impact on how we feel. So Chanuki, my colleague Tobias Preis, and I, we were looking at pictures like this. And we were looking at the vast number of photographs that are shared online today. And we were wondering, is there not some way that we could use this vast data set to get some sort of quantitative insight into the relationship between the way places look and how we feel? Now, the truth of the matter is, unfortunately, we do not spend most of our time on holiday in the Lake District as much as I would love that to be the case. So arguably, looking at data on how healthy we feel in the places we live is probably more important. So luckily, the Office for National Statistics here in the UK has some great data on that. And this data comes from the census that's carried out every 10 years that everybody in the UK is asked to fill out. Now, in that census, there's a question that asks people to report on how healthy they feel. So you can pick everything from very good to very bad. And so we were able to look at people who reported that their health was very poor or it was poor. Now, unfortunately, you can imagine if somebody's older, then they report their health to be worse. There is actually a difference between men and women as well. So men actually tend to report their health to be worse than women. So we need to take these things into account before we can work with this data. But once we've done that, we can plot it and it looks like this. So on this map, we're looking at data on poor health. So darker blue areas are areas where people reported better health overall. Areas that are green are where we saw higher prevalence of poor health. And you can see in particular, if you take a quick look at this map of England here, you can see that cities like London, like Liverpool up in the north, you can see Birmingham, you can see Manchester as well. You can see around these cities, we tend to see these lighter green areas. So people are reporting their health to be worse in cities. We might have thought as much. So we've got this national scale data, thanks to the ONS, on how healthy people feel. But the question we had was therefore, well, how can we get that sort of national scale data on how beautiful the places are that people live in? Now, thankfully, the answer to this question came to us in the shape of a game called Scenic or Not. So Scenic or Not is a game that was created by an organisation known as My Society back in 2009. I'm very happy to say it now lives in our lab in Warwick. Now, Scenic or Not shows you pictures like this, and you can rate them. So if you think it's very scenic, then you can choose 10. If you think it's not very scenic, then you'll pick 1. Or if you think something in the middle, you can choose a rating in the middle. Pretty straightforward. And those pictures in turn, they come from another online project or indeed game called Geograph. So in Geograph, you get points for uploading pictures in as many kilometre squares of Great Britain and Ireland as you can. And so on the back of Geograph and Scenic or Not, we have ratings for over 200,000 locations with over 1.5 million votes in total. So that gives us some quantitative data that we can plot, and it looks like this. So here on this map, darker purple areas are areas that got higher scenic ratings. Lighter blue areas are areas that got less scenic ratings. So I love this map because it shows apparently everybody agrees with me. That big, or one of the big purple areas you can see up in the north is the Lake District. So scoring very highly there, which is nice. If you look down towards the south, you can see there's a beautiful coastal area, Cornwall in England, that also scores very well. You might notice London down there in the southeast, not really getting those high scores. We're seeing much lower ratings. Again, as we might expect, it's not really going to compete with the Lake District on scenic appeal. Okay, so what we wondered is, well, what happens if we put this data together? What would we find? And well, what we find is that people who live in more scenic locations report their health to be better. Now, if you've just been looking at those last 2 maps, you're probably thinking, well, hang on, wait a minute, is this not extremely trivial? Is it not just we saw that people in cities were reporting worse health? We've just seen that London is not doing as well as the Lake District. Is this not just about whether people live in the city or not? We did wonder this too. And so we split England into urban, suburban, and rural areas. And we looked at all of those separately. And what we found was that in each case, even if you, for example, just look at the urban areas, it is still the case that people who live in the more scenic urban locations report their health to be better. Now, even with this question about cities out of the way, you might think, well, yeah, okay, but, you know, you're going to see socioeconomic differences in who lives in different urban areas. So, you know, maybe that sort of data might explain the sorts of patterns that we're seeing here. We wondered this too, you know, income is an obvious example. But thankfully, again, we've got lots of socioeconomic data like that. And so we put data on measures of deprivation in particular, so including income, into the model, and we looked at whether that could help us explain the differences that we saw. And while you do see that, unfortunately, income deprivation is associated with worse health, it's not enough to explain the differences, the effects that we see here of the scenic variable. Even with those things out of the way, you might think, well, yes, okay, but, you know, if you look at this photo, you might agree with me. You might think, well, you know, yes, very scenic, but it's also very green. You know, have we maybe just found a really complicated way of measuring how green different areas are? Now, again, we did wonder that. But thankfully, people have been able to measure green space for much longer than they've been able to measure how scenic areas are. So if you want to measure how green different areas are, you can get quite a long way with aerial photography. So you can just take a picture from above, and then you can look, well, you know, which areas are green. And so you can plot that data too. So here's a map. So if you look up in the north again, you'll see again, yeah, you know, the Lake District is on the whole quite green. If you look at London, you'll see London not so green. So, you know, there's some similarities here to the patterns we saw before. But if we put the maps right next to each other, you start to see that while there are similarities, these variables are not exactly the same. So one example would be if you look over towards the east of England, you'll see some areas that score quite highly in terms of green space, but don't score as highly in terms of scenicness. So what we wanted to know was, well, which of these variables would give us the best explanation of how healthy people report themselves to feel? So what we did is we built 3 models. We built one model where we tried to explain the data on how healthy people felt themselves to be using just the scenicness data, another model using just the green space data, and another model using the scenicness and the green space data. And in all of these models, we did also have these other socioeconomic variables in there too. And what we found was there's really very little evidence that you can afford to ignore data on how scenic places are if you really want to explain this data on how healthy people feel. So this graph, what it's showing you is essentially the weight of the evidence for these 3 different models, if you're trying to decide which of these 3 models is the best, right? So we've got probability of the scenicness only model being the best. That's it all in purple. The green space only model being the one we should go for in green. Or scenicness and green space, that's the stripy areas. And what you'll see looking at this graph is there's hardly any of these bars are coloured just in green, right? It doesn't turn up at all under all areas. And in fact, if you look at when we look at just urban areas, you'll see that the model we've got the strongest evidence for is, by this analysis, actually the model that just uses the scenic data. But looking at, you know, England as a whole, suburban areas, rural areas too, the main takeaway is there's very little evidence that we should not be using this scenicness data if we want to best explain the data on how healthy people feel. Now, we were really excited about this, that we had some, you know, first quantitative evidence that living in a more scenic environment was associated with people feeling healthier. There's a few things we need to bear in mind here. So a big caveat is that while I would love to be presenting strongly causal evidence here. I cannot tell you that this is definitely a causal relationship, that it's definitely the case that living in a scenic area is going to make you feel healthier. So we've got basically under the bonnet of the modelling a correlation here. And so one thing we can't rule out is that if people feel healthier, they might decide to move to a more scenic location. This is something we're trying to work on along with many other things. But so that is something you need to bear in mind at the moment. We can't say that this is a causal relationship just yet. You know, even if we could, we'd still have some questions. So we'd want to ask, well, if it were causal, well, why? You know, if you lived in a more scenic environment, why would that make you feel healthier? Might it be that living in a more scenic environment would lead you to go and do more exercise and then you'd feel healthier? Or could it just be that being in a more scenic environment made you feel happier, and then because you felt happier, you felt healthier? Now, this question of happiness, which I can associate with that, feeling happier in these more scenic environments. It's an interesting topic, happiness, because much like scenicness, it's something that has traditionally been very challenging to measure. So options that we've had in the past, if we want to understand whether something makes you happier or not, one option would be to do a study. So you've got a couple of situations, you do an experiment, you've got a couple of situations, you put people in one situation and ask them how happy they are afterwards, put them in another situation, ask them how happy they are afterwards. So you can try this approach, but one problem you'll tend to have is that this is very resource intensive. Normally that sort of experiment would only cover a small number of people or a small number of locations. Others have done, amazing work with surveys. They have asked thousands of people every year about how happy they're feeling. But because, again, that's generally been very resource intensive, these questions have often only been asked once a year and have therefore only focused on, how happy do you feel with your life? So like life satisfaction, rather than, did you feel happier when you were in that more scenic location than you do in this less scenic location? So great data, but not, data that makes it a little tricky for us to answer the question we really wanted to answer. Are people really happier in more scenic locations? So given the challenges that have traditionally existed in measuring happiness, we were delighted to start to collaborate with George McCarran from the University of Sussex here in the UK. And George had developed an app called Mappiness. Now, Mappiness, if you installed it on your phone, would ping you a couple of times a day, and it would ask you how happy you were feeling. It'll also ask you a couple of other things. So who were you with, for example? What were you doing? And on the back of Mappiness, we have over 3 years of data for over 15,000 people who've told us how happy they were feeling in all sorts of situations, and crucially for us, all sorts of different locations as well. Now, with that level of happiness data, you can see some simple patterns. So, for example, I can tell you all, you only have to wait one more day and then life should be looking a little better. So good news, the weekend is on the way. On the downside, the data would suggest that people here in the UK, it was a UK study, people here in the UK may not be in the best of moods as a result of our chilly October. So I guess I'm just hoping that those of you watching this in the Netherlands are feeling a little happier while I'm giving my talk. But yeah, we've got a while to wait till that one gets better. But these sorts of patterns aside, we can ask the question that we would have had such difficulty asking before. Are people really happier when they're in more scenic locations? And the answer is yes, even if we take all sorts of other things into account. So let me flag up straight away that in order to not overload your eyes or your brains, this figure only has a really small subset of the things that we could measure in the Mappiness study. So we've got data on what people were doing. We've got data on whether they were in a natural habitat or a built up habitat, how much green space there was around them, whether it was an urban, rural, suburban area. There's also other data that didn't fit on the graph, like what was the weather like, or who were they with? We talked about that before. Loads and loads of variables that might affect how happy you were feeling. But even with all of that built into the model, we see that moving from an area with the least scenic rating to an area with the most scenic rating is associated with an increase in happiness, which is, roughly speaking, about the same size as the boost that you might expect from listening to music or from talking, chatting, and socializing. It's about the inverse of the slump in happiness that traveling or commuting tends to cause, no one's favorite activity. But crucially, we were talking about how scenicness can be confounded with things like green space. We see that this holds, even if we take into account whether an area is built or natural, even if we consider the percentage of green space, and even if we look at whether it's an urban, rural, or suburban area. And even if we actually just exclude all of the data, other than the data from people who gave us ratings in built up urban areas, we still see there is this order of magnitude of jump in happiness. So even in cities, yet again, we're seeing that being in more scenic locations is associated with greater happiness. So we told planners about these results, and they said, well, that's really interesting, but what makes an area more scenic? And we said, oh, okay, we'll go and look into that for you. And then we slunk off and looked with some trepidation at our pile of 200,000 photographs, all of which had ratings. And we were, initially reduced to just trying to find some photos with the highest ratings, maybe in cities, and coming out with a conclusion like, well, we think people like bridges. Obviously, right? If you put all this effort into turning this question into something which is finally quantitative, doing this computational work, that's not the sort of hand-wavy answer you really want. So thankfully, it didn't take us too long to realise that there was a much better way of doing this, that while our little brains were not capable of processing all the information about these 200,000 photographs and honestly telling planners which were most scenic and why, we could, of course, get a computer to help us with this, specifically a convolutional neural net, a kind of AI. So what we did specifically is we used Places CNNs. This is a convolutional neural network that was developed by a team at MIT. What we did is we fed each of these 200,000 photographs into the convolutional neural network. And what it then outputs is over 300 features, so values for over 300 features, telling us what's actually in the image. So for example, if we put this beautiful photograph in, scores a 10 on Scenic or not, then we see from the output from Places CNN that there's a valley can be seen in there, that a lake can be seen in there, get something about a mountain. We also get some attributes of the scene. So for example, we see a high score for natural light. And so then what that then means is we had, for our 200,000 images, we had not only the scenic or not ratings, but we also had values for over 300 features. So finally, we can build a model to see, well, okay, which feature or which features are associated with people giving images higher scores. Now, you can imagine some of these features are going to be correlated, like valleys, mountains tend to turn up together. And so we needed to build a model that could take this, could cope with this sort of correlation. So we used specifically an elastic net. So if we throw all the features in and look at what explains the data on scenicness. So what we see is we find that photographs with lakes in there are scoring highly. Photographs with valleys are scoring highly. So this is all looking rather aligned with my love of the Lake District. We also see that photos that look like industrial areas, not looking so good, or indeed buildings that places CNN thinks looks like a hospital, not scoring very highly either. So we look at those results in the first instance, this all looks a bit obvious, right? Looks like grand natural elements are leading to higher scores, and built areas are not doing so well. Again, the sort of simple explanation we could have thought of to start with. However, if we dig further into the data, for example, we focus again on the built up urban areas that many of us live in, then we see it's really not that simple. So for example, there are built elements that do lead to higher scores. So buildings with character, like cottages or castles, for example, or, to my delight, bridges. So we weren't totally wrong there. Bridges, viaducts, aqueducts, they also lead to an increase in the scenic rating, despite the fact they are, again, built elements. On the flip side, we see that not all green space is the same. So trees are associated with greater scenic scores, but grass, flat areas of grass, like athletic fields, for example, actually, once you've taken everything else into account, are associated with lower scenic scores. So if you look at these results, you start to see why we didn't see an exact match between the data on green space and the data on scenic ratings before. It's not the case that all green space is the same. And I think this is important because traditionally, most work that's looked at relationships between the environment and our health and well-being has focused on green space because it's been so much easier to measure, as we were discussing before. But what we're seeing here is they're not the same, and you need that data on scenicness to give the best explanations of how healthy or happy people feel. So we were relieved that we had a better answer for the planners. But there was still one thing that was bothering us a little bit. Namely, the way Scenic or Not worked was that we had one rating for every kilometre squared, which gave us some great coverage. But if you start thinking again of urban areas, 1 kilometre squared, it would be great if you had more ratings than that for cities. And indeed, Geograph does have many more photographs than that in cities. So if we could have denser data in urban areas, or indeed anywhere these photographs were available, that would be fantastic. So we thought, well, if you can get a convolutional neural network like Places CNN to tell you what is in the image, could we not make some changes so that that network could actually tell us how scenic the scene was? So that is exactly what we tried to do, and it worked. So what we did is we took Places CNN and we basically told it to stop trying to tell us what was in the image, get rid of that output, replace that output with a scenic rating. And then we trained it further. So we got it to learn more than what it knew before using transfer learning, so that instead of telling us what was in the image, it could predict the scenic ratings of these images. So take a look at this map. This is a map of an area of the centre of London. The dots are all Geograph photographs, and the colour is how scenic the AI we developed thought the photograph was. So if you look at this map, you'll see some patterns pretty rapidly. So you'll see, okay, green areas. The Scenic AI has drawn blue dots all over them. So blue, more scenic, red, less scenic. So we've got blue dots all over the green areas. You can see there's some red dots elsewhere away from those green areas. And so indeed, when we asked the AI, okay, tell us which you think are the top 5% most scenic locations in London, you would see areas come out that were natural and green, like, for example, here, Hampstead Heath. But again, the story was not that simple. So in line with the results that we had seen before, it wasn't just about natural and green areas. If you looked a little further, you'd see beautiful buildings such as Big Ben, or indeed the Tower of London, also coming out in that top 5%, despite being, again, built elements rather than natural elements. So by drawing on AI and crowdsourcing, we've been able to generate measurements of something which has been really obvious to us as humans for many years, but near impossible traditionally to get data on at any sort of scale. So the beauty of the environment that we spend our time in. We've been able to use that data to show that scenic areas are not just green areas, and scenic areas are not just natural areas. Indeed, it seems that scenic areas are not just a nice to have. They could be as important for something as critical to all of us as our health and our happiness. Thank you very much.
Thanks for that. That was really amazing talk. We have some time for questions in the room. So anybody have any questions? Great.
Yeah, thank you. That was really beautiful and inspiring. I learned a lot, and yeah, I realize it's much more difficult than in my field of chemistry and physics, where things are more, let's say, black and white, and you do an amazing job in trying to establish boundaries and checking and double checking everything. And I was wondering if you could say a little bit about how what tools do you have to do such checking, and so for example, yeah, you mentioned causal relations, and this is of course very difficult, and you mentioned maybe obvious causal relations that where you, if you live in a scenic part, then you are more healthy, but it could be the other way around. Maybe if you don't feel so well, you go to a hospital, and the hospitals happen to be in cities, and that's why you go to cities. So what sort of tools do you have to check for hypothesis, and maybe the next step, even come up with hypothesis, or so in machine learning we would say feature spaces that you would not think of automatically by yourself? Are there ways to have the machine learning tell you maybe of things other than is it green, or is it scenic, etc.?
So that is a great question. Thank you very much. Let me come to your first super important point about causality. So I am always interested to hear about other people's ideas on this topic because it's so crucial. But at the moment, my position on this is that demonstrating it's really a causal relationship is mostly about ruling out all the other possible explanations. And so that is the approach that we're taking at the moment, is trying to see, well, what are the other explanations that could give us this effect and that we can eliminate. So, for example, we've done things I didn't have time to touch on today. Pollution. You might expect maybe that could be playing a role. So we've taken data on pollution, we've plugged that in, we've ruled it out. So we've tried to think, well, what are the other explanations? And we're trying to work through so that we can rule those out, so that we can strengthen our argument, or indeed disprove this hypothesis that there may be a causal relationship between living in a more scenic environment and feeling healthier or indeed happier. But again, any suggestions, I'm always interested to hear them. I would love there to be a tool that made our life a lot easier, but I think that's the slog approach that we've been taking so far. And you also asked, well, is there something that we can do to find alternative explanations that we might not have thought of? This isn't something we've done so much in this area, but it is something we've done in other areas. So we had in the past looked at data on what people were searching for on Google, and subsequent stock market moves. And in some initial work we did on that, we found relationships between changes in the amount of interest in financial topics and subsequent stock market moves. That was based on a fairly simple hypothesis, right? Financial topics seems like the most obvious thing that somebody would look for if they were interested in the stock market. So with that initial, we've got a hypothesis approach, we found a result. But we did then also turn the question around, and we found a way of generating data on searches on a very large number of topics, and then basically throwing everything in to see, okay, well, which topics are really associated with subsequent stock market moves. And what came out of that was still the relationship that an increase in people searching for financial topics was associated with a fall in certain prices the week later. But we also saw that an increase in people searching for political topics was associated with a fall the week later, which, you know, with the benefit of hindsight, seems really obvious, and you wonder why we hadn't thought of it to start with. But, you know, I think that experience for me highlighted very much the value of the kind of approach that you're talking about, to see if we can throw up other things that we haven't already thought of. I suppose one of the reasons that we haven't done that quite so much here is that some of the things we'd like to look into is just harder to get the data. So with search data, although it wasn't super straightforward, it was possible to just go to the same search data source and extract data on lots and lots of different topics. But here we're talking about all sorts of different things in the world that might affect this relationship. And so we generally find it takes us longer to access the data, which makes it harder to throw everything in at once.
Great. We have time for, go Denny here.
Hi, thanks for a great talk. I was wondering, have you considered using this kind of thing, the AI, for instance, to help people who develop plans or who are architects? You could imagine that in architectural training, people use these digital tools to construct new environments, and that you could sort of give them feedback on how scenic the things are that they develop. And actually, I think it might not be very bad idea to help people developing cities actually using that kind of thing. Did you have any plans in that direction or considered it?
So it's a great question. Yes, we have spoken to people involved in planning and in architecture, but I'm always delighted to have more conversations in that area, because obviously these people come with an expertise different to ours. But so we have had those conversations. I do, and I strongly agree with you that this sort of data should be useful for development of cities. I wonder if we might have a hard time persuading architects that they should use it on individual projects where they might feel that their own judgment of one image that they can see is superior. One thing that the tool could perhaps add is, well, what's the general opinion on this, which might differ to the architect. So there'd be some interesting data there. The place I think it's most interesting or most useful is where you can give councils, planners, people involved in developing our cities, deciding what should be built, what should be knocked down, where you can give them that data at scale, because that's where it gets tricky for a person. In the same way as we were slightly overwhelmed trying to say anything sensible about even 200,000 photographs. There's like 6.5 million on Geograph, and you can imagine we could find even more photos than that. So it's being able to look at those measurements at scale rather than just making a judgment on an individual basis, as you might be able to do as a human. We can scale up past human capacity and show people, you know, where a hidden gem is, for example, or where an area is that perhaps needs some more attention. And it's not just planners we do this with. We work with people, for example, like the Canal and River Trust here in the UK, who are in charge of looking after rivers and canals. And we're helping them similarly find the hidden gems, and also maybe find places that need a little bit more resource to go into them to make sure that they're the asset to the community that they should be.
Thanks. We have time for one more question.
Yeah, I suppose you're familiar with the work of Judea Pearl on causality, and I was wondering if you were able to hypothesize a model explaining happiness and environments, and if you could, on conditioning on your data, on elements in your data, try to come to explanations in terms of happiness in relationship with the environment and kind of convolutional elements in there. I hope I'm making.
So I understood this was about referring to previous work on causality and looking at whether we could get a better understanding through that sort of approach of why happiness might be associated with being in a more scenic environment and what might be a confounding variable. Again, with the happiness data, we're in a good position that we have a lot of data on variables that might be associated with happiness that might be confounded with the scenic data. So maybe people might be more likely to go to a scenic location at the weekend or something, or when they're on holiday. That sort of thing we can take into account from the Mappiness data, and so we can try to rule that out. But it does leave questions about the underlying mechanism that we'd still want to answer. There are, large amounts of work on topics like the biophilia hypothesis, or there's basically a large body of work in environmental psychology that we could try to fit these results into. But I think we've still got a long way to go to be able to pin down a really full model, and we offer what we've got here as building blocks for that sort of model to be developed in the future, as it hasn't been possible to see these relationships at scale in the past. So I think we share an ambition that we would love to make progress towards the sort of goal that you're describing, although we acknowledge that there's still quite a long way to go.
Great. Thank you so much. That was amazing talk. We'll end it there. Yes, now I can see you. We're looking at the videos. Thanks so much. Let's give the Suzy another round of applause. And thank you for taking the time to come and do hybrid conversations with us. I think it worked pretty well. So enjoy. Thanks. Bye.
Thank you.
So we've come to the, there we go. So let's see, here we go. So we've come to the end of Data Science Day. Thanks for coming. We really appreciate it. And I hope you learned something about data science, about interdisciplinarity, about all the amazing work that's already being done here at the University of Amsterdam. And we're here to help you. And we keep building this community together, and we're going to do that in the future as well. This day is very complicated, having a hybrid setup, having in-person setup, Corona check passes, all the infrastructure. So I'd like to thank Jean and her whole team. Yeah. And thanks to our AV guys, and thanks to Julia downstairs for organizing that. And our library folks for doing a good job on the Twitter stream. That's always important. All right, so with that, now we have the fun part of being in the Netherlands, right? So we'll have a borrel and some networking after that. Please keep in touch. We'll have more things coming for you. please connect. If you need anything from us, you know where we're at. Yeah, have a great rest of your Thursday, and see you soon.